Hello everyone and welcome to yet another recreational programming session with Mr. Zozin as usual. So we developed our coroutines library, and for those who doesn't know, coroutines are sort of like a lightweight threads, user space threads that you basically switch between manually. So there's a better description on the README page of the library itself. The link to that specific repo is going to be in the description. I really recommend you to read. So, and we were developing this entire thing with the sole purpose of integrating it into our own WebSocket library. So our WebSocket library is kind of finished, sort of like a semi-finished. It passes all of the spec tests and stuff like that, but the only problem that this library has is that it's synchronous. It's written in a completely synchronous fashion, and because of that, it's kind of difficult to use it for multiple connections. You still can use it for multiple connections if you use multi-threading, but the problem of using multi-threading in network applications is that majority of the times your threads are going to be doing is just waiting on some I/O. So it's kind of a waste of operating system threads, right? So, and the usual approach in here is to actually use asynchronous input-output. So while you're waiting on I/O on one connection, you can go and do something else with other connection. And so coroutines in here are actually perfect for that, right? So because they're not real threads. Right, so there are user space threads that you switch between manually, right? So, and they have an interesting operation yield. I think we can even go into the source code of the coroutine library. Coroutine.h, coroutine yield, right? So here is the function call. So yeah, so if you call this function within a coroutine, the execution will switch to a next coroutine, right? So there's a little bit of a scheduler going on in there that basically decides what coroutines to switch to, and they just sort of kind of round robin and switch between each other, right? So if you feel like you don't have anything to do right now, for example, you don't have any input or any available output on a particular connection, what you can do, you can just yield and let other coroutines do something else, right? So it's kind of perfect for that. It is kind of perfect for that. So what I want you to do on today's stream, I want you to finally integrate these two libraries, right? So we have coroutines that work at least on x86-64 Linux, right? And that's the operating system I plan to use this library in anyway. So let's just go ahead and see how we can do that. It should be actually kind of difficult. The sole purpose of actually implementing this library was to make minimal amount of changes to the WebSocket library, right? So let me actually see how we can even approach all of that. So the server is located in here. It is called Echo server. I'm pretty sure that's what it is. And yeah, so here it has a loop and it accepts connections, and for each connection it actually creates a thread. By the way, this language is called C3, right? So if you're not familiar with it, it's just like C, right? So I can give you the link to the website of this language. It's not particularly special. It's not that different from C. If you know programming, you can kind of understand this language anyway, right? So, and it's not about the languages anyway. It's about the problems that you solve with the languages. Right. So what we're doing here, we create the threads, and that's how we actually, maintain several connections. And this is something that I want to change on today's stream. Let's see how we can even do that. So if I try to build everything, so hopefully it will, yeah, it already builds. So I would like to maybe build it in several threads. Right. So, but to build it in several threads, I would like to maybe employ make files instead of all of that. Yeah, so maybe, yeah, let's actually migrate to make files. I think it's going to be a good investment of our time. Maybe, I don't know. Maybe it's a bad idea. We'll see. Right, so our main target in here, I would say, is probably Autobahn Echo server. So that's basically the asynchronous server. And it depends on a bunch of things, right? So it depends on all of these things. Right, so all of these files needs to be compiled into this specific executable, and the way you compile this specific executable is something like this. But what's important is that it also depends on having the build folder, Right, so that means it kind of depends on having a build folder like this. So let's actually create a target that simply creates the build folder, right? So, and I think that's about it. So I can go and just like make, and as you can see, it does in fact make it. So that's pretty cool. So we can now actually do the targets for the rest of the things. For example, for the Autobahn echo client. So, and all of the dependencies for these things are these and also build, because we are creating this executable within build. So now I can say something like all, which basically depends on all of these things, right? On all of these things, and if I want to build all of these things, I can actually build it into threads. So it, as you can see, it runs them simultaneously. So that speeds up a little bit of work, especially on the multi-threaded environment. So let's actually introduce the third executable in here. So it's actually kind of easy. I didn't expect that to be so easy. That's pretty cool. Okay, so, and it also depends on build, and let's include this thing in here as well. There you go. So if I do just build.sh, how much time does it take? So as you can see, it builds them sequentially, and it all takes almost 4 seconds of time. But here I can actually employ shit ton of threads. And so did I forget something? Yeah, I forgot to actually build this thing. Yeah, there we go. So, and as you can see, it builds them simultaneously, and the time it takes is actually, yeah, it's actually half of that time, because all these things are built in parallel. Fuck bash.sh. So we're going to be using makefiles now. Right, I don't know. So C3 has its own build system, which I didn't really particularly like. Right, it's too goddamn simplistic. Right, it doesn't allow you to do arbitrary things. Like, it expects you that the only thing you're gonna do is just like build executables, right? That's it, right? So just like it's kind of simplistic for my taste. A particular build system, yeah, a particular build system. Maybe I just don't understand it. Sometimes I feel like maybe I just don't understand the genius of C3, but I'm trying really, really hard. But like I just don't fucking understand it. I don't really know why they didn't go just like a, you know, knob approach or something where you build with the same language. So it's kind of bizarre to me. Just a bag of opinions. This language is just a bag of opinion. That's what it is. It is a programming language, though. It is a programming language. It is usable for things. You can write programs in it. I'll give it that. Okay, so let's do something like replace build.sh with makefile. That's what we're gonna be doing, and that's what we're gonna be pushing. Let's fucking go. So let's actually see if this server still works. Does it still fucking work? I don't fucking know, mate. I don't fucking know. So Autobahn echo server, okay, so it is listening to this particular port. If I remember correctly, somewhere we had tools send client HTML, right? So we had a client, a WebSocket client written in HTML. Well, I mean, actually in JavaScript. So I'm going to open Firefox in here. And as you can see, we successfully connected to the server, all right? So we successfully connected to the server, and I can say hello. As you can see, the server detected that we sent 5 bytes and we actually received hello back. And now we can even open the second one, right? So we can kind of maintain 2 connections in here, I think. And for all of these connections, it will be creating, you know, separate thread. You can't really see that it actually returned me hello world or something. I wonder if I can do something like that. Oh, yeah, you can see that. Look at that. So here is the hello, here's the world, and that's the responses from the server. That's the responses from the server. Isn't that cool? I think it's pretty freaking cool. But again, it creates separate threads for all of these shites. So echo server, like, why can't I see that? So how is that called? Autobahn. This motherfucker doesn't filter shit. Yeah, okay, so I think I found a way to do that. Look at that. Look at this motherfucker. Look at this motherfucker. You are not resizing the right thing. Okay, thank you so much. So here is the Autobahn echo server, and it created 2 freaking threads. Did it kill them already? I don't know what is going on, but here are the 2 threads. And for each freaking connection, it is going to be creating a separate thread. So look at that, it creates a separate thread. So I open another thing, it creates a separate thread, and so on and so forth. That's kind of wasteful. That is kind of freaking wasteful. So particular window management. It looks like you guys like this word. Okay, anyways, any fucking ways. What I want you to do, by the way we can actually confirm that this WebSocket implementation is legit is by using the Autobahn test suite. Do you guys remember this shit? Autobahn, yeah, WebSocket Autobahn test suite. Right, and we managed to actually make it work on our machine. I'm gonna put it in here, and maybe I'm gonna even put it in the description. Maybe I'm gonna put it in description. So let me actually see if it still fucking works. I don't fucking know, mate. I don't fucking know. I don't fucking know, mate. I don't fucking know. Maybe my code has rotted so fucking much over the course of implemented coroutines that I have to re-implement everything yet again, because that's how modern software development works. That's how modern software development works. You can't really do anything about that. Your code rots. Your code is dead on arrival. So, yeah. So everyone is going to be writing prompts instead of code. So then LLM always generates the freshest version of the code. So it can rot on the next day. So we're going to be regenerating it from the prod yet again. So that's the future of software development, isn't it? That's the future of software development. But to be fair, so far LLMs generate kind of like old versions of the things. I heard people complain that sometimes the API of certain libraries change and LLMs don't really adapt too fast. They're still using the old versions of the APIs. General intelligence my ass, by the way. So, so anyways, so let's actually try to see if I still can run my, you know, things, right? So here it is. Can I now do, okay, so here's the test. And I don't remember, so there was like a mode. So let me see, is it help? Yeah, I think it's something help, and there was a mode. I should have actually left myself like in a readme how to run yeah, Zozin, what the fuck is wrong with you? Why didn't you document how to fucking run Autobahn test suite? Are you some sort of noob or something? Like, what the fuck is wrong with you, Zozin? I swear to God, how the fuck do I run this? I don't remember. So there is a mode. Okay, so I do remember that. So there is a mode test. Mode, I think it's a fuzzing client, right? So maybe it's a fuzzing client. Or maybe, can I? Okay, so here is the fuzzing client. Okay. Boom. Holy shit, it is working. It is fucking twerking. Look at that. Look at that. It is testing. So it is fucking stress testing. It is trying to annihilate our server, but the server is resisting. Look how fucking stable it is. And it's done. It is done. So what it's supposed to do, it's supposed to generate reports. Right, so did it generate it in the right place? So we didn't say where to put reports. Okay, so the reports are in the server. Okay, so Firefox reports, reports server and index HTML. So let's take a look at the report. Okay, look at all of these greens. Look at all of these greens. This implementation of WebSocket is legit, and I implemented it from scratch in C3. Look at that. And it's fucking spec compliant. It is fucking spec compliant. This is how real software developers do things. They just don't do npm install. They just sit down, open up a fucking spec, and implement the fucking spec. That was the worst way, like a waste of my time ever, honestly. But I mean, it's kind of cool. I kind of know a lot about WebSocket implementations, WebSocket spec, and I kind of know how fucking garbage it is. So it cost me, I don't know, my mental health, I suppose. What I'll tell you, it's better not to know how shit the WebSocket spec is. It's better not to know that. So do not re-implement it from scratch for your own good. It's not, the problem is not it's difficult, it's actually easy. it's better not to know how shitty it is. Just like it's kind of a little bit of an info hazard, right? So just don't do that. It's not difficult, right? That's not the problem. It's just like then you're gonna be even more cynical and you know. So don't do that. Don't learn how the sausage is made, okay? Don't learn that. It's like it's better not to know how the sausage is made. Just enjoy the sausage, okay? So it's tasty, it's delicious, it's good. Just it's better not to know what the fuck they put in there, okay? It's better not to know that. But anyways, so how all of that works? So the library is actually like kind of tries to abstract away the notion of a allocators. Right, it is trying to abstract away the notion of a allocators. Just enjoy the sausage, sold in 2025. Okay. All right. So, and you know what I was thinking? Okay, so it uses operations like read, right? As you can see, it penetrates deep into the socket and it just calls the method read of the socket. Another method it cares about is close and another one is write. So essentially, it only cares about 3 methods of the object it's working on because socket is kind of a generic, right? So it's a generic parameter and it expects it to have 3 methods. I was thinking how I'm going to be integrating coroutines with all of that stuff. I may actually create a special kind of socket, which is a asynchronous socket, right? Which wraps around the TCP socket. And when you try to do a read or write on this asynchronous socket, what it will do, and this is actually a very important part, before actually calling the read or write of the underlying socket, it's going to call sleep write or sleep read. These 2 operations, sleep read and or sleep write, which accepts the file descriptor of the socket. This is a very cool function that we developed for coroutine libraries. What it does, it puts the current coroutine where the WebSocket is running to sleep. And it's not going to switch, the schedule is not going to switch to this coroutine up until something to read or write on that specific file descriptor is available. That way, the entire library doesn't even need to be aware that it's running in a coroutine. What it does, it just calls reads and writes and close of the, of the socket. Right, but the socket has such implementation that every time you do read or write, it just switches to another socket if there's nothing available to read or write. Isn't that cool? I think it's pretty freaking cool because one of the things I remember, a member of our Discord server with the name Spiritman was complaining that he wanted to find some implementation for a protocol in Rust. And that implementation for a protocol was depending on Tokyo. So just to quickly use that implementation of a protocol, he had to, fetch an entirety of fucking Tokyo. When in reality, he didn't even want to use it for multiple connections. He wanted to use it for a single fucking connection, just asynchronous one, right? So, and it brings in this entire framework, and it's just freaking annoying. A fucking classic. Oh, Spiritman is in the chat, yeah. So you know what I'm talking about. So your rant actually kind of like, influenced my architectural design decisions of the libraries that I make, believe it or not. Right. So for you it was just like a brief rant, but for me it kind of stuck in my head because that is kind of true. That is kind of true. And this approach is kind of cool in a sense that the library doesn't give a shit. You want just synchronous sockets, you feed it synchronous socket. You want asynchronous sockets, okay, you feed it asynchronous socket. The library doesn't even need to know that we're integrating with coroutines. That's a fucking cool thing, I think. So yeah, so this thing will work in synchronous mode, in asynchronous mode. Hopefully, we haven't implemented that yet. Maybe it's not even possible, but we're gonna try. In theory, it works, right? And it's like it doesn't give a shit. It's all abstracted away. Ranting about bad software does help confirm. It does help because somebody may actually hear you right? And then they may not even say anything, but they may start doing things, right? They may start doing things. You guys remember how I ranted about, you know, kind of a stupid decision in Python 3 when you do help? What it tells you is that just print help for actual help, right? And I ranted that, like, motherfucker, you know my intent. You fucking know my intent, you still decide not to do that. And I ranted about that over several years. And as far as I know, like several other people picked up on that rant and also amplified. And look at that, they fucking improved it. So, like not directly. It's just like I kind of started the message, and then I saw other people starting to repeat this entire sentiment, right? Because they probably heard it in one of my streams or one of my clips, or something like that. And there you go. They fucking fixed it. I didn't even have to create an issue. Like, imagine going through this entire process of creating issues like a fucking peasant. It's just like begging, please fix, please. Who fucking does that? You start a meme mocking the developers, and developers get pressured into fixing it. I'm joking, please don't do that. But I mean, it's more effective, isn't it? So... It's just like, you know, reporting issues is for peasants. It's just like, who am I? Unpaid QA intern or something? Reporting issues. Anyways. So, I'm a peasant. Same. I actually also report issues quite often. I'm just joking. Don't take me too serious, please. Alrighty. How are we gonna be organizing all that? So let's fucking go. And I want to make my server actually single-threaded. I want it to make single-threaded so I can start applying coroutines. Chat. Are you following your coroutine? A daily coroutine. So what we need to do in here, I suppose I can just go ahead and comment out all of these things. Can I? So essentially, all right. So here we're accepting the connection, right? So we're accepting the connection. And we don't even have to do these kind of things. We can... So this is just a client. All right, so I can just do a client. I don't even have to do that. It may fail. Then I enable debug, and then I say serve. Okay, so I'm going to be actually removing all that stuff. So I'm removing all of the multi-threaded craft. I'm just removing all of the multi-threaded craft. So, and let's just go ahead and try to rebuild this thing. And here is this thing. So this is good. And I didn't want to do that. Bravsky. I didn't want to do that. Okay, so it is complaining, which is good. Where it is complaining. So let's find out. So return 1, it didn't like that. So it probably wants just a return. But I think we should return an integer because I want to be able to return a non-zero exit code. So then it kind of indicates that an error has actually happened. All right, that seems to be working. That's pretty cool. So now I'm going to close this entire thing. So, and I'm going to open the HTML page. Do I have the HTML page somewhere here? So is that the HTML page? No. This is just like a circuitry. Yeah, there you go. So that's opened the connection. So that's pretty cool. And let me put it somewhere here. So I can put hello in here, world. But then if I try to open another page, look. There's nothing saying that we actually connected to the server. Only if I close this thing, only then it will say connection is established. So this is a single-threaded server, right? So essentially it basically makes the second connection wait until the first one is finished and stuff like that. So this is exactly what I want. Right, and starting from here, we're gonna try to introduce our coroutine, our daily coroutine. So let's actually see what we can do in here. So first of all, we need to bring the coroutine to the to the library. I should stop. So so in coroutine. So coroutine can, I suppose, consists of actually 3 files, right? So there's a header file. I'm not sure if we need a header file, right? So because it's only for C. But I mean, .c uses kind of this file, so I suppose we need to bring all of them. And C3 is basically a bindings for this entire stuff. Okay, so let's just go ahead and bring the coroutines into our WebSocket library. So I'm gonna just select all of that stuff. I didn't actually open WS I said, and I'm just gonna copy this in here. Okay, so one of the things we want to do, we want to actually kind of build the O file, the object file and stuff like that. So let's go ahead and fucking do that. So this is going to be coroutine.o, and it depends on coroutine.c, right? So, and here we're going to be doing GCC. So we're going to enable all of the warnings and some of the extra warnings, and maybe even enable some of the debug symbols so we can debug this thing. So, and then I'm going to say, okay, compile it as a, you know, as a single translation. I don't even know what's the official terminology for that -c. Is that a separate compilation? Like, what does it even mean? I remember that it basically compiles like an object file without creating a final executable with entry point and shit like that. But what's the terminology do they use to describe this flag? I'm actually really curious. So yeah, they do mention -c in here. So let's actually find, okay, so was it saying dumb? Oh, my brain actually read it as dumbass, but the dumb. Okay, so all right, just let me see. So -c, for example, the -c option says not to run the linker, but they don't really say what the fuck it is actually. So, and there's not that, and there is a shit ton of flags, and it's impossible to even find this thing. I wonder if I can find it by saying, okay, so here is the beginning of the word, the boundary of the word, and it didn't fucking help even in a single bit. So space -c, space, okay, that's better. Okay, that's better. So we're going somewhere. All right, compile or assemble the source code, but do not link. The linking stage simply is not done. The ultimate output is in the form of an object. The ultimate output. I really like this phrase, okay. In the form of an object file for each source file. By default, the object file name for a source file is made by replacing the suffix c with stuff. So I suppose -c stands for compile. It stands for compile. Just compile, but do not link. Okay, got it. So that's what it is apparently. Cool, but we want to place it into the build, right? So we want to place it into the build, and because of that, it kind of depends on the build, right? So it kind of depends on the build. And so let me actually rebuild the whole thing now. And I didn't want to rebuild the whole thing. I actually wanted to rebuild the object file. Does it compile? Okay, so as you can see, it actually compiled the object file, but it created it in a separate space. Right, it created it in a separate space. Okay, thank you so much, Aki237, for wasting a bunch of money for gifting community subs. I don't get any money from that at all. So if you wanted to support me, you just wasted money. But if you wanted to actually give 10 people access to the Discord server, well, you achieved your goal, right? So the only point of having a sub in here is to get the access to Discord server, because again, I don't get any money from that, because I do not deserve that, because I was born in a barbaric country. So anyways, thank you so much, Develop Land, for the other stuffs. Thank you for all content. Now I understand coroutines too. You're welcome. You're welcome. So Metisaf777, thank you so much for the resub with the message. 73 months learning about how coroutines work with Zosin. Yeah, so it is what it is. I also understand how coroutines work. Well, kind of. I think I understand how coroutine works on this like a fundamental level, but I think I haven't figured out what's the best API for coroutines, right? What's the best API, right? So do yields are yields supposed to actually like return some values? Should you have some sort of like a communication mechanism and stuff like that? So because some of the languages, they allow you to return some things. Some languages also employ some sort of like a channel mechanism and stuff like that. So yeah, so I haven't figured out what gonna be the best kind of API, but I hope as I integrate as I integrate this library into the futures library, the required things are going to be more obvious, right? So the required things are going to be more obvious, and maybe that will sort of drive the design of the API. So we'll see how it goes. We'll see how it goes. C++ has the best API. I heard that adding coroutines to C++ was a nightmare because of the craziness of the runtime of the C++, right? So because C++ like has a lot of shit like exceptions and virtual methods and stuff like that, destructors, and all of these things, and like all sorts of situations may occur, right? You can't just save the state of the execution on the stack. You can't just fucking do that in C++. So there's a lot of things, right? So there's a lot of things, right? And honestly, like implementing coroutines is insanely easy if you just don't use C++. In fact, everything becomes insanely easy if you just don't use C++. It's kind of interesting, right? I feel like C++ at this point becomes like a sunken cost fallacy, a sucking cock fallacy. So that's what it becomes. Like every time you use C++, it's a sucking cocks. You know, speaking of the cock routine. Oh. Speaking of the cock routine. Anyways. So we managed to build the here is an interesting thing. If you try to build a program in C3 that links with an object file, let's actually try to do that. It's kind of interesting, chat. It is actually kind of interesting. So I'm going to create a module which is called foo. I'm going to import stdio fn void stuff like that. So print fn hello world, right? And then I try to build it. So it's going to be foo c3 and then coroutines c3, and then I say also link it with coroutines. Did it create it? Oh yeah, it didn't create it in the build folder, so we'll have to fix that as well in O. So file name must be non-empty and followed. It has to be c3. Yeah, the coroutine could not be found. Did you create the O file or not, Motherflipper? Did you create it or not, or did it actually destroy it? Yeah, that's what I'm talking about. So here it is, and then I try to do that. Yeah, so the motherfucker just sucks up the O files. Like, why the fuck is this doing that? The motherfucker just sucked up my O file and destroyed it. Now I have to create it again. Like, this is, what the fuck? Like, I don't know a single language that does that. It's just like, where is my O file? It's just like, for this language, object files are like consumables. It just consumes them. So sucked what? Sucked that. Gobble gobble. Yeah. But you know what I found? You know what I found, chat? So first of all, we have to place that into the build, right? So let's place that into the build. It doesn't suck up the A files. It doesn't suck up the A files. So do you guys know what is an A file? It's a static library, right? It's a static library. But do you know what is a static library on C? It's just an archive of O files, right? So essentially now we can create something like coroutine A, which obviously depends on coroutine O, and you create A files using R utility. So create, modify, and extract from archive, but this is not archive, this is actually static libraries. So, and I do that in the coroutine library in here. So let me see, so it's R, yeah, so this is the flags I'm using in here. So what this thing does, it just takes the O file and places it into the A file. Right, so that's what it does. So now one of the things we can do, we can just do make, right, and as you can see, it built it O file and it placed it into the A file. Right, so to make it a little bit more, you know, obvious, I'm gonna create it in here. So now, if I try to build, but instead of linking with O, I'm gonna be linking with A, yeah, I have to actually, I think I have to use a special flag -L in here, right, to link with this entire thing. And it linked with that, but it didn't gobble the A file. What is going on with this goddamn compiler? Why is it gobble O file but doesn't gobble A files? What is going on? It is the most bizarre compiler I've ever seen in my entire life. I haven't seen anything like that, like, anywhere. It's just doing its own thing. It's like, what's the criteria of files that it gobbles? Does anybody know? Is there some sort of a spec? Right? It's just like, what the fuck is going on? It's just like, oh, sometimes it feels like I'm programming an intercall, right? Do you guys know what is an intercall? Intercall. It's like, well, can you do that in English, please? Intercall is a Terry programming language, yeah. So basically the point of that language is that it may just randomly not compile. And it may not compile because you were not polite enough. So you have to say enough keywords, please. But you have to be not over polite, otherwise it's also not gonna compile. Right? It's just like... Anyways, so that's the language we're dealing with. So that's the language. It gobbles the O files for whatever fucking reason, but A files, it doesn't like A files, right? So it doesn't eat them. Anyways. So what we got in here is this thing, and so funny enough, I think I want to actually do something like this. So it depends on build, but this thing also depends on build, but the build is going to be created by this thing anyway, so it's kind of totally fine. All right, so this is Autobahn echo server. So now we're going to say that this thing depends on that, right? So it just depends on that. And we're going to link with this entire thing in here. So we're linking with that. But on top of that, we also want to link with coroutine C3, right? So .a files are multiple use, .o files are single use. Yeah, so that's probably how it works. Single use files. I don't fucking know, man. It's just like... it's so bizarre sometimes. Okay, so yeah, we're linking with the coroutine library. How cool is that? Is that cool? I think it's pretty freaking cool. Have you tried passing please don't gobble flag? Haven't tried it yet, so yeah, I'll try it at some point. Gobble. All right, so what do we want to do in here? I'm gonna go into the well, it's just like an echo server, right? So it is in fact an echo server. And now, yeah, I'm gonna just import coroutine, right? So import coroutines. That's pretty cool. And the first thing we can try in here is to initialize the coroutines. So coroutine init. There we go. The coroutines have been initialized. That's pretty cool. That is pretty cool. So everything seems to be working. So I might as well even try to run Autobahn echo server like this. Seems to be working. And do I have the thing in here? No, it's not that one, it's this one. So we established the connection. Nothing is broken so far, which is great. I'm super happy about that. So the next thing we need to do, we need to, I don't even know, we need to start marking TCP server socket as asynchronous. That's one thing. So if I remember correctly, let me actually take a look at the echo example in the coroutine, right? So coroutine comes with its own echo example. And for the TCP server, what we're doing, we're just like taking an inner socket of the server and marking it as non-blocking. This is one of the things we probably need to do in here. So we're marking it as non-blocking. And now here is an interesting thing. So TCP accept automatically becomes asynchronous, so it may fail with E again. So because of that, I think doing this kind of like thing is not particularly great in here. I want to just make this entire thing true, right? So this becomes true. Right, and we are accepting the client and we're getting TCP socket, and it is optional, right? So it obviously may fail. But before trying to do this kind of thing, we can say, okay, the current coroutine sleep until there is anything for read available. So the thing about accept, right, is that if the socket is non-blocking, accept unblocks when there's something to read. So accepting a connection is actually reading, right? So that's what it is. Because of that, it makes sense to actually sleep in here, right? So we're just sleeping in here, and after that, if we don't forcefully wake up this particular coroutine, this call should never fail with E again, right? And for those who doesn't know, E again is an operation, is an error that happens when you do a read or write or any sort of IO operation on a non-blocking thing, right? And usually this error happens when the call is supposed to block, but since the file descriptor is not blocking, it didn't block, right? So sometimes it's also known as E would block. As far as I know, these two values have the same number. Right, so they do have the same number. So if we didn't forcefully woken up this particular coroutine, this call after sleep read is not going to fail with E again, right? Because that's kind of the whole point. That's kind of the whole point. So anyways, right, now we're doing the accept. So we accepted the connection. After accepting the connection, we also need to make this particular socket as non-blocking. We can steal this particular call in here. Now all of the read and write and close operations become asynchronous in here. Right, and all of this code is effectively broken, right? So because this entire library is kind of written in a fashion that it expects reads and writes to block. So I think this is where we start implementing a new sort of abstraction. Let's call it async TCP socket. Right, so, and it's going to have an internal, right, so inner socket like this. And for this entire thing, we're going to just implement different methods, right? So we're going to implement 3 methods, read, write, and close method. So let's go ahead and do that. Maybe I can steal the signatures of these methods from the standard library. Let me quickly see. So I'm going to go into that net TCP and let me find something like TCP socket read. Actually, it's probably defined within the socket. Alright, so TCP is actually socket read. This is the thing I'm looking for. Okay, so it's even dynamic. God damn. I don't remember what dynamic stands for. Like, dynamic means that it is a... Ooh. It is a freaking interface. But okay, so we're gonna just ignore the fact that it's an interface. We're gonna make it like this. Right, maybe it would be a great idea to also implement the in-stream and out-stream interface in here, but I don't think I need to do it right now. In any case, so where is the right thing? So this is another thing that we need to have in here. So this is going to be async TCP socket. Right, so socket. It's not going to be dynamic for now. And the last thing is probably close. Right, so yeah, it's just destroy, and I wonder where it's coming from. So close is probably coming from one of the one of the interfaces in here, instream or outstream, maybe all of them. I don't know. We'll see. We'll see. So, and how we're going to be implementing all of these things? This is a good question, I think. So for read and write, right, as already said, we're going to first call coroutine sleep read. So we're going to self inner sock. And I don't remember. I think that's it, right? So it's just like an inner sock, and it's going to be considered like a file descriptor. And only then we're going to forward the read call into here, and then return this entire thing. You see that? So this is basically the trick that we're going to employ, right? So we're going to be sleeping, kind of a blocking coroutine, until like some reading, some data is available for reading, and that will effectively, you know, reschedule to that coroutine. All right. So and then here we can do basically the same, but for writing. Right, so this is writing situation in here. And honestly, I don't really know how closing works. So when you close an unblocking socket, what is happening, right? I don't really know. So we might as well just like return self inner close, right, and hope for the best. So right, so that's basically the idea. Excuse me, I'm kind of losing my voice. So I suppose now what we have to do, we have to replace this with async TCP socket, right? So this is async TCP socket, async TCP socket, async TCP socket, and we're gonna say that the inner is equal to the client, right? Client. So that's basically it, honestly. That's basically it. So this one is also asynchronous TCP socket. So after that, what do we do? I think, nah, this one is more interesting. So we have to create actually a coroutine. We need to do the coroutine go. Right, so let's go ahead and do that. So if I remember correctly, in coroutine C3, there we go. So here is the go thingy. Yeah, let's fucking go. Coroutine, go. And we have to create a function. So coroutine fn, so it just doesn't accept anything. So fn, and it accepts some sort of an argument in here, which you pass usually here. So the kind of an argument we're going to be passing in there, I suppose, is going to be the client, right? So we just created the client in here. Right, we probably also want to unwrap it, right? Because we are sure that it's not going to, like, you know, fail with E again. And if it failed with something, it is not E again, which means that we want to report that anyway. Right, so we do this kind of thing. And honestly, I actually want to clone the client, basically move it from the stack on a heap. So then it survives the next iteration of this entire thing. That's what I want to do. Right, so and then in here we kind of own the client now, so I can even do something like client, and I can force cast this entire thing like this, right? So it becomes something like that, you know, arg. So after that, at the end of this entire thing, I can defer freeing this entire client like so. Accepted a connection. All right, so we accepted a connection. The next thing we have to do, is do this kind of thing, and we are already in a separate coroutine. All right, and here we just return. I suppose we can just return something like this. By the way, you can never return from a coroutine with a failure. Maybe this is something that we should enable at some point. I think that would be interesting. But anyway, so this one will just do the serve. And when you do the serve, I think it is serving in a some sort of like a loop. So Autobahn echo, yeah. So you do the serve, yeah. It has a loop and stuff like that. So and it's sending frames and stuff like that. So that's fine. That's fine. Yeah. So the problem here is that this thing is a pointer. Right, and our async TCP socket doesn't accept pointers. So maybe I'm gonna quickly say that this is going to be pointer because it's just gonna make it a little bit easier. Now, I think that's it, right? Believe it or not. So we just create a wrapper. Instead of threads, we're using coroutines, and that's basically it, isn't it? I think that's basically it. Right, so let's try to rebuild that, and obviously it doesn't build because I forgot semicolon. I'm sorry. Freaking semicolons. 73. Almost spent 3 hours debugging, and with a single missing semicolon. So 75. So it doesn't like 0 in here for whatever freaking reason. What the fuck is that? Warning: this code will never execute. Ah. Technically true. Impressive control flow analysis. Impressive control flow analysis. All right. So what else do we have in here? So socket. Oh. Ooh. So support set on a level of, and it's. Oof. Where are we? So it failed. Huh. C3WS C343. Ah. Okay. Well, I mean, yeah. Well, we should be able to shut down, I think. Yeah. Let's freaking go. So if I do, like, take a look at this thing. When I do shut down, yeah. So the freaking socket doesn't have a shutdown method in its interface. Like, what the fuck is this scheisse, meine Freunde? What the fuck is this scheisse? So, you know, I think we can kind of enforce that. We can create our own method in here, and it's going to be shut down. Right. So it's going to be fn, I don't freaking know, async TCP socket shut down, and so I don't even know. So here we're also providing the reason for the shutdown, right? So not really reason for the shutdown. What is it called? Does anybody remember what is it called? So yeah, it is called how. I wonder why, I wonder how. Yesterday told me about the blue sky. So it's yeah. So it basically the which end of the socket do you want to shut down? Is going to be a read end or write end, and so on and so forth. Socket shutdown. Yeah, very funny chat. So let me take a look at like what's the signature of the shutdown in the C3 standard library. I don't freaking remember. So shutdown. Let's fucking go. Okay, so there's a threads and some other stuff. A shutdown. Where is the fucking shutdown, mate? Where's the fucking shutdown? I don't fucking see that. Are you telling me? Bro! It doesn't even have it in a standard library. I had to literally freaking forward declare it for. Oh my god. Oh, yeah, I'm even able to do consider submitting these definitions as a PR to C3. It all brings back. Holy shit. Yeah, so there's a lot of things that are kind of missing in C3, and I just like added these declarations, and I was kind of lazy to submit them as pull requests, and I put it to do in here, and now this bite me back in the ass. I should have actually submitted those things as pull requests now. So now I'm having like a little bit of a trouble and stuff like that. Legacy code base, yeah. I kind of have like quite a few to-dos on submitting. Yeah, like a peasant. I have to go and submit it like a peasant. God fucking damn it. Small indie language, please understand. And ironically, you're making it as a joke, but C3 is literally like a pet project. It's not even funded like by a big company or anything. It's literally a pet project. So, so it's just like, as far as I know, there's like a big companies behind like languages like Zig and Odin and stuff like that. It's literally a pet project of one person, by the way. It's just like, yeah. And because of that, it's kind of impressive, right? So, yeah, it's usable even. Anyone coding using DeepSeek? How about sip a dick? Oh, sip on that. I'm sorry. Yeah. And what we need to do, we need to actually maybe bring this entire scheiße somewhere there. Echo server C3. So let's actually bring it in here. So that's what we're going to be doing. And yeah, so we have several definitions in there. And we're going to do cint how. All right, so self, inner, and might as well do something like this. So this one is going to be self, inner sock, and how. Right, is it going to return anything? So as far as I know, it has a notion of like a socket error of some sort. Right, if this thing is less than 0, then you can just go and do socket error. Socket error. Just a second, chat. Let's grab it up. I think it's called socket error. Yeah, that's what it is. Right, so that means you can just return this socket error, and that will effectively work, hopefully. And socket error, how is it even implemented? So where is the FM? Yeah, so you do convert over error no, right, and it just like converts it into one of the C3 errors and stuff like that. So it kind of integrates the libc error handling with C3 error handling. That's what it does effectively. Yeah. So all right, so now we have a shutdown method, which is great. Right, I really like that. So C3WS. We don't need any of that stuff anymore. We don't need this check. So this one is going to be WS socket, like this. And yeah, so we're gonna actually put exclamation mark in here. So if it fails, it will short circuit and return from here. So that's what we kind of expect in here. All right, let's go ahead and try to finally build the thing that we're trying to build. Where's my make file? Let's fucking go. Okay, next compilation error. Happened in C380. All right, let's fucking... Oh shit. We're employing peak. So because we're peeking into the input that we got, and this is not part of the interface of the socket. Oh shit. I made a lot of shortcuts, apparently. Add something like socket peek to the standard library and make it PR to C3 maybe. Yeah, another situation where it would be kind of nice to have a you know, this part of the interface and also make a pull request to the thing. Okay, so let's fucking go. We're gonna make another method in here, another method of the async TCP socket. 2 hours later, yeah, I mean, we only spent like 1 hour, right, so this one is going to be use size, right, so async TCP socket, so peak, and in here we're going to be just accepting the bytes, the bytes. This one is dynamic. I have no idea why the fuck did I make it dynamic. I think at the time I didn't know what dynamic even means, so that's totally fine, I suppose. Alright, so this is... I might as well just like grab all of these things. So that's what it should be. And honestly... yeah, maybe I will move this entire thing to here. Yeah, I'm moving this entire thing to here. Fuck you. So WS peak row. Yeah, we don't need this method anymore. Like everywhere we use this method, we should use the method of the async TCP socket. Yeah, that's what we should be doing. So this is the method that we're using now. Right, so, and it's a part of libc anyway. All right, so let's go and try to rebuild this entire thing. So it doesn't like First parameter of the method must be a type, async something. Oh yeah, it's true. It's true. Yeah, let's make it a reference or something like that. So here we do self inner. Right. So this is the inner sock. That's what we do. Okay. So now it's complaining about all of the places where we used to use pickroll. Right. So this is where we used to use pickroll. But now what we have to do socket and just pick. That's what we're doing in here. And here is another interesting thing that I forgot to do. So this is receive. That means we have to do sleep read on this entire thing. There we go. Right. So because we are doing the coroutines and stuff like that. Okay. So what else do we have in here? This is another pick 138. Socket pick row. Let's fucking go. Okay. Compile. It actually fucking compiled. Interestingly, when we're doing all of the logging and shit in Echo Server, I would like to also print the current coroutine, but it's kind of difficult because the server doesn't know that we're running within the coroutine. Right, so we have to kind of like tell it or something. So in here we can always do something like coroutine ID, right? So this is the coroutine ID. But then, where is the echo? C3. Here, as we receive things, we don't really know that we're inside of a coroutine. Right, we can kind of import that, but I mean, it's not going to work with the code that is not coroutine aware. Right, it's just like, it's kind of a temporary thing. Coroutine ID, but I want to be able to see this kind of thing. If we did everything correctly, this should just work and be asynchronous. And if it does work, it's going to be amazing. But I actually doubt that. We probably will have to employ a little bit of a debugging, debugger-wogging. That's for sure. Oof. Temporary allocators. This could be a problem, chat, because we are basically allocating everything within temporary allocators. And so that means those things are sharing a temporary allocator. So for each individual, for each individual coroutine, we'll have to create our own allocator and destroy it in here. I think we need to create a separate allocator. Even though coroutines, they're not threads, so two coroutines can actually share the same allocator, and it's fine, believe it or not. It is going to be totally fine. The problem here is that each coroutine is going to reset its own allocator. That's the problem, right? So that's where they're going to start conflicting with each other. So, and when we are allocating some memory within the, within the library, are we always using the temporary allocator? So I think we always, I think I always just employ the temporary allocator. I see. Always employing the temporary allocator. I have a feeling that we should make the allocator part of the WebSocket. Right. So let me actually show what I mean. So WS, where is this struct? Oh yes. So here it is. I think all of the allocators should be the allocators of the WS. Yeah. So when you create the socket, you also create the allocator for all of this stuff, right? So it's going to be allocating it. That allocator should be reset every time, like on each iteration or something like that. So, but I think I want to make a small break because I'm already streaming for 1 hour. I ran out of tea. So I'm going to make a cup of tea. And after I make a cup of tea, we're going to, introduce a separate allocator for each individual WebSocket and stuff like that. I think it's kind of important. Sound good? Gucci? Tamaguchi? We're back. So let's go ahead and maybe create new temporary allocator. So let's see how it's gonna go. So I think it's located somewhere in a memory module, right? So there should be probably part of the core, right? And there is a mem temp. So I'm looking for a temporary allocator, and I wonder if I can easily find it. So it was a function temp, right? Yeah. So there you go. So allocated temp. So that means I can probably find that specific function by doing some sort of a clever grep that's doing a fen, then skip some stuff and then TMP or something. And I found it. Okay, so here it is. So this is just temp, but it returns. This is incorrect actually. So it's probably not a fen, it's probably macro. Yeah, got it, got it. So here is the temp allocator. So what is it doing? It's looking for, yeah, so as you can see, it's a thread temp allocator. So it's a thread local, right. And also it is not initialized, right? So one of the way, what it just does this kind of thing. So to initialize a new temporary allocator, it has two temporary allocators. That's bizarre. But anyway, create default size temp allocator from a temp base allocator. So what is a temp base allocator? So it has a base allocator. Okay, so all right, and it's just like creates a base allocator. Okay, so this is probably how we have to do that. And is this private one? Okay, so at least it's not private. One way we can do all of that is that now when we do echo, not really echo, but echo server, right? So we go here on top of, you know, just creating WS when we accept a connection. Maybe we can do that within the accept method. This is actually kind of cool. This is actually kind of cool. We can try to do that within the accept method. All right, so where is the C3WS? Where is my accept method? So here it is. Here we just say that this is not a client or whatever. And this is where we can create an allocator, right? So we're gonna call it TMP. So based allocator, and in here, this is just an allocator. So that means I can just call it an allocator. Struct WS, yeah, TMP, like this. So that's pretty cool, I think. That is pretty cool. I wonder how do I deallocate the allocator. So TMP was create default size allocator. But how do I just, okay, so you can destroy temporary allocator, but it destroys the default one. So how does it destroy individual? Okay, it just calls destroying them. Okay, that's pretty cool. Now, as we close the socket, I think we can destroy the allocator as we close it, can't we? Right, so you just do the shutdown, you close all of that stuff, you close the socket, and you might as well just take your temporary allocator and destroy it. There we go. So this is one of the things you can do. Does it fail with anything when you destroy? Okay, so it doesn't really fail with anything. That's pretty cool. So each individual socket is going to have its own temporary allocator. Are you creating coroutine functionality? Creating? I already created. Who do you think I am? All right. So now we destroy this stuff. I need to go through all of the places where you do alloc. I just like generally temporary allocation. Where do we do general temporary allocation? Okay, so here what I have to do WS TMP now, right? WS TMP. Okay, this one is interesting, right? So we do temp new array. Temp new array, but it underneath what it's doing is just using tcalloc, right? Yeah, it's kind of annoying, right? So new array, but can I specify the allocator for the new array? Yeah, I can do something like this. Okay, understandable. So I could just do something like this. Allocator. The allocator I'm using is WSTMP. The type and the elements is this. kind of thing. So this is how I can now replace this entire stuff. So that's pretty cool, game. That's pretty cool, game. So let's try to make the whole thing one more time. Well, I mean, I haven't finished replacing the temporary stuff, so let's find the rest of the temps in here. Okay, so WS temp. That's another one. Next one. Okay, kind of similar, but not really. Let's find new array. So now we're going to be replacing this stuff with that. Right. But we have to do it like this. So I'm going to put that stuff in here, then a boom. All right, so that's one thing. Temporary allocator. Oof, oof, oof. We don't have WebSocket in here, even though we should be able to have it. Okay, so one of the things I suppose here we have to do, we have to accept the allocator now. So this is allocator. We're gonna put it in here. So this is the allocator now. And I think that's it. That was literally it. So now we have to go through the compilation errors because we did a little bit of refactoring. That's cool. That is actually super, super cool. So now I'm gonna do that. So what are you complaining about, mein Freund? Allocator interface has no method. I think I know what is going on. I think I know. So where is the, yeah, so allocator pair should have, yes, should have used this type. All right, so let's fucking go and just like replace this thing with a beta type. So that's what it should have been. Well, and honestly, we already call this variable temp, so it has to be appointed to the temp allocator. Understandable. Absolutely understandable. Okay, so what kind of error do we have in here? Okay, so this one is expected, right? So what we have to do is just like put a temp in here, but what I have to do here is temp allocator pointer, right? So okay, that's kind of working. So create default size. Are you freaking shitting me, Brovsky? And it's even local. Fuck you, Leatherman. Fuck you. Okay, so I probably have to use one of these things, right? So it's like I can't use it probably. I probably can't use it unless I actually do something like allocator, create. Maybe this is what I have to do. Allocator, hater. Yeah. Fuck. Shit. Fuck. Damn. Excuse me. New temp allocator. Where this thing is defined. Mallocator, yeah. Your mamacator. Oh. Ooh. Yeah, so it has to be just part of the allocator. I see. So which kind of allocator we're going to be creating? We're going to be creating like a big one, small one, environment variable. Let's create this big one. 256 like kilobytes is nothing, honestly. It is actually kind of nothing. So I'm gonna be using this one. Though I'm not really sure what 256 is even. So I don't even know. And it is using like a base allocator. All right. So that's what we're doing in here. Might as well even short circuit it like this. Yeah. So let's go in here. All right, so double allocator. Temp base allocator. So you're telling me it's not available, right? So, but what if I just do something like this? Yeah, it's not private though. It is not private. So I'm not really sure why. It is fucking private. But I mean, I can just do something like a base allocator then. So Who is the base allocator? Ah, I see. So can I just do something like this then as a function? So, oh, it's not a function even. Is that what you're trying to... Well, why do you use it as a function then? I'm so fucking confused. Like, so it's one of the... It's one of these things. Well, I mean, I can explicitly tell you that it's a libc allocator. And it's a pointer to one of these. It's kind of bizarre. I just want to create a temporary allocator. Okay, so I finally created a temporary allocator. I'm not going to be using this library in WASM, so whatever. This like standard library of C3 is kind of convoluted. Like the question is why? Why there's so many like this thing, and some of them are private. Like why is it private though? I want to be using that outside. I want to also be creating my own temporary allocator. Like what the fuck is going on? Why is it so obtuse and convoluted? Like what the fuck? It's just like it doesn't have to be this way. Like what the fuck is going on? Sometimes I wonder, what the fuck is going on? It's just like layers upon layers upon layers upon layers, and it's not even OP. That's what's funny, right? It's not even trying to be OP. It's just like creating layers for no freaking reason. Maybe I'm just don't understand something. And once some of these things are private, all of a sudden, it's just like, what's the obsession with making things private? Like, what's that? I don't freaking understand. Anyways, okay, so I created a new allocator based on libc allocator, and it's just like a, you know, big enough for things. So that's cool. So now this is an echo server, and as I serve things, right? As I serve things, look at that. So what I'm doing in here, using the global one. What I need to do is now I need to use the one that comes with the socket, right? So. Yeah, here's the mark and shit. Oh, and this one is rather interesting. We don't have to reset this thing anymore because as you close the WebSocket, it's gonna even deallocate the whole temporary allocator. So we don't even have to do that anymore. So temporary reset, and now what we can do in here is just wtemp. Okay. So yeah, each individual WebSocket has their own allocator, temporary allocator, like an arena or something. So, and on each iteration, we're just like cleaning it up. We're just cleaning it up. Right. Are you happy now, my friend? Are you happy now? Let's fucking go. Compiling. Are you ready for a little bit of a segfold chat? Well, it didn't segfold right away, which is already a good sign. Okay. So let's go to somewhere here. Oh. Okay. Accepted a connection. Can I send some shit? Okay, I can send some shit. I just accepted second connection. Motherfucker just worked. Holy shit, that's so fucking cool. This is single-threaded. Guys, this is single, like, I can create a bunch of more things, right? So I can create even more. So, and we're maintaining actually several connections. We're right now maintaining 4 connections. And I can now do htop. And where is the sort functionality? I think it's a filter. Autobahn. Yeah. There's only one single thread. There's only one single thread. CPU is 0%. And we're handling 4 connections. And it just worked through coroutines. Holy fuck. And we're also handling closing the connections. Holy shit. It just worked. The idea just worked, and I did like a very minimal modification to the library. The library is asynchronous now. I just have now a synchronous WebSocket library out of nowhere, just by slapping coroutines that I implemented myself, like using assembly or something. I'm surprised this works. What the fuck? Oh. The thing is, like, this is a huge hack. Like, look how coroutines is implemented. This is a yield function that switches between the threads. This is the kind of shit we do. And it works. And like, we do that on a low level in C, then we link it with C3, and all of that just works. I think more like set jump. I mean, whatever. It's the same shit. Can DeepSeek do that? DeepSeek can sip my dick. I'm sorry. I'm sorry. It's just a joke. It's just a joke. Please, Chinese Communist Party, please don't kidnap me. I think we should run some, some tests on this thing. Minus 50 points. God fucking, I've lost my social points. I lost my social points. Now stress test. Yeah, let's actually stress test. But the thing is that stress testing works with a single thread. I wonder if I can make it multi-threading. That's a good question. So test suite, I didn't. Do you guys see anything? I don't think so. Right, so because for each individual test case, what it does, it just connects, does the test case, and disconnects. So it's always a single thread. Though one of the things we can do, while it is testing things, we can connect through the browser and shit. Is Autobahn test multitasking? I don't think so. I don't think it's testing multitasking. Right. Mod mass connect, does it have a mass connect? I didn't see it. Oh, mass connect. Mass connect. So we're gonna try that. But first, what we're gonna try is just a regular fuzzing, right? So regular test case, test suite, just to see if we didn't break the library or anything. Mass connect. What's up? Why am I still repeating this ancient fucking meme? Somehow, I'm such a boomer, I swear to God. Some old ass meme just permanently damaged my brain, and I'm pretty sure I'm gonna be repeating that dumb meme until the rest of my days. 2015 brain rot. So yeah, I think this is gonna be a thing with old people in the future. They're gonna be screaming like fucking idiots memes that nobody fucking remembers. Right, imagine me in the year of 2016 screaming what's up, big connect, while sitting in a soft room, Anyway, so let's actually try to test things. Mode fuzzing client. Let's fucking go. All right, so it's doing things. It's not crashing, at least. Gen Z is the new boomer. Gen Z is like a 25 already, I think. Gen Z is getting older. I think they're approaching their 30s. I'm pretty sure they're approaching their 30s. I'm a millennial. Haha. I already don't give a shit. Okay, so Firefox. All right, didn't break shit. Still working. Still, as we say in the industry, twerking. Okay, so what I want to do is I want to open these things, right? So it's not these things, but this one. Okay, so the connection has been established. I can do things, it responds. I'm gonna now try to run the test suite yet again. As you can see, it's doing that on a second coroutine, and it's still responding to my messages even though it's doing like a test suite. So it can find time to respond to my messages. I can do another connection, and okay, so it's perfect. And again, it's not using operating system threads. It's using our coroutines. Man, I'm so fucking happy. I'm actually proud. I've never been this proud about my code for a long time. Because like I didn't just use some library. I went from the fundamentals, from the assembly. I understood how the entire execution goes, implemented the concept of coroutines, and embedded it into my networking library, and it just works. I can't fucking believe that. Holy shit. So let's try to do the mass connect. Mass connect. It doesn't do anything, so. Okay, so what does it say even? Python 2 is not, okay, so it's just, you know, random shit. Okay, so it's using maybe some, yeah, I don't fucking know. Oh, it's connecting to, yeah, 9,000, but we're listening to 9,001, I'm pretty sure. Yeah, it's listening to a wrong port. Okay, so here's the mass connect. Yeah, you're listening to a wrong port, motherfucker. So, I mean, connecting to a wrong port. Let me try to do this kind of thing. Okay, so I'm gonna change this stuff. And let's do mass con. All right. Okay, so I actually killed it. How many? Okay, so let's try to connect. Connections 10,000. Okay, let's actually start small. All right, so let's start with 1,000. 1,000 connections. Boom. Oh shit. I think it killed something. Yeah, because I did Control C or something. All right, let's fucking go. All right, it's getting there. It's getting there. Did it do it? I don't know. Like, is it? What is it doing? Well, I mean, it's kind of handling them, right? So, but it didn't go to 1,000 connections or anything. Why is it stuck there? So 967 is the limit. Yeah, probably. I don't even know what's up with that. So, but I mean, it's maintaining some of them. Right, we can reduce that to, I don't know, this. So I just want to see what's going to happen when it reaches its limit. Right. All right. Oh, okay, and it also starts actually sending some shit to them. Connection to. All right. I don't even know what it does, right? So it just sends some stuff. And it's kind of handling them, right? So we're gonna actually test that when we integrate this library into our game, because all of that is actually to completely rewrite the backend of the coil game in C3, because right now the backend is written in half JavaScript, actually TypeScript, and half C3, and we're compiling C3 to WebAssembly so we can actually call the logics, hold the logic of the server from JavaScript. So, and the only reason why we're using JavaScript on the server is because of the WebSocket implementation, right? So to completely rewrite the server in C3, I had to roll out my own WebSocket implementation with my own coroutines, and I fucking did that. I'm so fucking proud of myself. So yeah, I guess I'm gonna call it a day, right? So I actually implemented what I wanted. I didn't expect that it's going to just work. Right, so let me actually maybe commit whatever I have in here. Right, so here's that. I also need to clean it up a little bit, right? I don't want to commit it right away, right? So because I did a bunch of hacks and stuff like that, this is not really the, you know, form, the final form of the code that I would like to commit. So I'm gonna clean it up a little bit off screen and only then gonna commit, right? So because it's a little bit sloppy. It's a little bit of a sloppy code, if you know what I'm talking about. A little bit of a sloppy code. All right, that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Ahu Mr. Azuzin. I love you. Mwah.